Okay, so the only difficult part here becomes, guess what, impedance. Finding impedance might be the tough part right there, or is it? Let's see, Z is equal to V over IT. Well, it's not that bad now, because I already have I total, and I can actually put that in there now. So let's go ahead and put that. V was 80 volts. Let's put the angles in there. Angle of 0 degree. Because if I don't say anything, that means 0 degree. And I total is 18.9 milli. Angle of minus 32 degrees. So now I can find Z. What's 80 divided by 18.9 milliamp?
4.23K.
1.23?
K, yeah.
Yeah, 4.23K.
2K. Let's put the angle there. Angle of this from this numerator becomes positive. 32 degree. 32 degree. And that's Z right there. You see?
So every time the voltage doesn't have a degree, it's a 0 degree, pretty much.
Yes. If you say nothing there, that means it's 0 angle 0 degree. Most of the time that's going to be the case. Very seldom, I don't think it's going to happen in our course, but very seldom that will happen. I will be more like engineering level type of course where we have more complex circuits. But anyway, we just want to get the concepts here. Anyway, now,
You said on the
yeah.
you said on the VT, the total voltage,
Yes.
it will equal the voltage load or the voltage inductor versus the voltage capacitor.
Right, and then inductor and resistor. Yeah, because that was the definition of parallel circuit, wasn't it? What was the definition
The
of parallel
voltage
circuit?
equals
Voltage the same.
same
Okay.
parallel.
So if that's the case, then things are not going to change now.
So you don't. So the only time you have to worry about a voltage drop is if it's in series.
Series.
Okay.
Or we have series parallel. That's not the case here. It's true parallel circuit. If I have series parallel, that would be a different story. But right now, if it's a true parallel circuit, purely parallel circuit, that's good. By the way, pure inductive, or try to say not pure, but
Ideal inductor, they
Ideal
call it.
inductor means that it has no resistance, you know. So in other words, your resistance, let's say, you say 60 ohms, and you say, okay, use an inductor, and the inductor is ideal. That means that don't consider that inductor has like maybe a couple of ohms that you can add that to the resistance and to make things complicated. So in a sense, when it says ideal, this means don't worry about the resistance. Just go ahead and deal with the inductor like we have been doing. So that's why we consider everything is ideal. Okay, now all calculations that we do. Well, that's it. I don't think there's much more I can say. I can probably find about power. The power is not going to be any different than we have been finding. Power would be same formulas of power. I mean, piece of x is going to be same thing as, well, v squared. We can use v squared, or I squared times x of l, whichever we already have I. I would like to use I squared x of l most of the time. And for piece of r is I squared r. And P apparent doesn't change, by the way. It will be the same as square root of piece of x squared plus piece of r squared. So fortunately, those formulas don't change. Everything is the same. So that is it. There it is. Parallel circuit. I know the shell makes it much more difficult than it really is. He talks about admittance and this and that. And I could do that too. But I think this method right here is simple and straightforward. And the way that I like people to learn it. There might be a question. You might say, well, what if the voltage wasn't given? Then that would be a different story, which I will probably approach that. Maybe I should do that now. Do you think I should do that now before?
We would have to have current, wouldn't we?
Suppose I don't have any current or voltage. Can I still find Z? How do I find impedance? if I don't have it. So let's go ahead and do that for just the sake of argument. Should we do that?
Yes.
Sure.
Let's do that for the sake of argument. Let's say I didn't give you this thing here. See, I didn't give you this right here. I said nothing like that. I said, okay, that I give. So obviously I can't find I, can't find I12. That's dead. Everything is off the wall. Okay, so what do I have to do now? Everybody got this already? I can erase it? Look at that. I expect you to have this in your notes, but this is gonna make it, I don't think the book goes like it in this way or the shelf, so it's good to have another version of it. And the book likes to do this method. When you do this, it likes to say that, okay, the Z, use product over sum. Do you remember product over sum? Was R times X of L divided by R plus X of L. But, you know, it looks kind of easy like that, but it's not, because these are vectors. So I can't just put X of L in there. I have to actually put the angles. And that's what makes things, make things a little more difficult. So let's take a look at this and see how we approach that. So over here, R, which is 5K, and times, X of L is 8K. We know X of L angle is, X of L is, in this case here, 90 degree. And over here I have R, which is 5K, plus 8K is actually a J, or angle of 90 degree. Well, right away you see what's going on here. One is that this is in rectangular format, that's in kind of polar, so if I want to add something, I cannot add this way. I'm going to have to convert that in order to complete this here. This is your vector add. So let's go ahead and do this. So on top I get a Z equal to 5 times 8.
40.
40 mega.
40?
40 mega.
40, now this is K now, okay? I have another K, and another K, I have 2 Ks here, and I have angle of 90 degree right there. Now, I have
40.
to make, yes,
40
I say 40 times 10 to the 6th, right?
yes, I just put KK.
Okay.
That's 1,000 and 1,000.
So make you
It's like
can
K
put-
squared.
So it will still be mega too, right?
Yeah, mega,
Okay.
but it's fine.
Okay.
I just put KK this big, you know, that
You do that.
there's a couple of Ks in there. see?
Okay.
K, K, 2 Ks.
Different way. Okay.
I know it's silly, but what I'm gonna try to do is I'm gonna try to eliminate those Ks at the end.
Sounds good.
This K and this K cancel all the other stuff. So let's just left it like that. Then down here I have 5 and 8, so 5 and 8, now we gotta do is, it's gonna be, in this case here, it's convert it from the rectangular into polar. So that will be square root of 5K squared plus 8K squared, angle of
0 plus 90, it would be?
Really?
Just 90, because it goes 0 plus 90?
No. This is R and this is X of L. So the angle here is going to be how much? Alright, so angle of, going to be your tangent of,
Negative 32?
our tangent of, I'm talking about in this case here R, X of L, your tangent of 8K over 5, right? Is it 8K over 5? What's 8 over 5 arctangent of that. 8 divided by 5, take your arctangent of that. What is that?
57, 58 degrees,
58 degrees.
negative 58.
58 degree?
Yes.
58 degree. No, it's
Oh, yeah,
positive.
positive 58.
Positive.
Positive.
Positive. So, now, what is this one here? What's 5 squared plus 8 squared?
Well, it's gonna be a whole bunch, 'cause it's 5K.
5k squared. Just keep it in terms of k.
Oh, in terms of K?
Yeah.
Okay.
This 5 squared and 8 squared.
25 plus 64.
How much is that?
9.4 K.
9.4k?
Yes.
Well, this k,
Oh, yeah, true, it
This
just
K-
cancels out.
Cancel.
So you got
okay, a
40
couple of
K.
k's cancel right away. Now, 40 divided by 9.4. What's 40 divided by 9.4?
4.24K.
4.23k, okay.
4.24.
Like that's what I'm trying to make it to look like
Okay.
that one. And what's 90 minus 58?
38, 30, 32 rather.
32, and that's our answer right there. You see that? Get the answer?
Yes.
Oh, yeah, oh,
Matches this. So we made both methods to work. We can do product over sum.
With no voltage.
It's not that pretty, but as long as you keep your head straight, you can. We had to do a little conversion here. We had to do from, this was like a 8J thing, it's a J in there. So I had to like convert that.
so if this was like a parallel capacitive, to do it that way, you'd have a negative 58, right?
This,
Okay.
we're gonna do it now.
What
Thanks.
form, what formula do you use from 90 to 58?
Which say?
What formula do you use for that
Yeah,
one?
4.25.
Subtract.
Five.
You subtract 90 minus, when you divide, you actually subtract angles.
40 K divided by.
Is that what
No,
you're saying?
I'm talking about like,
1.4.
you know, got 5K plus 8K.
This, yeah,
Yeah.
Yes.
How do you get 48 right there with the formula to get?
it's
No,
9.4.
to get
Same
58
thing.
degrees.
It's close.
That's the answer, is
The
9.4.
58 degrees. The 58 degrees, right? What did you
58
use?
degree, okay. We did 8 over 5, we take an arctangent of it.
I got more like 4.26 on that.
Because remember, we
Yeah, that's
had,
what I got.
Yeah.
4.26. It's close enough.
Yeah.
we had that whole idea of
Oh, I see
polar
it.
and rectangular. And so I just did, I converted this polar form, because it's actually polar, it's 8kj. I converted that into rectangular. To do that, first you do the magnitude, and then you do the phase angle of these two vectors. This vector is a vector of 0. See, I didn't even put that 0, but to make it confuse, I could probably put a 0 in there, and put another 0 degree in there too. These are all 0 degrees, but anyway, I just omitted that. And then over here, then we end up with angle of 58 degrees.
Okay.
And that is the way, I think the book goes this direction. I like that method myself. I like both of these methods, frankly. What I don't like is actually using the admittance, which is used in the shower, heavy duty conversion, basically a discussion about that. So as long as you can do this, we're good with RL parallel circuit. Are you good? Are you guys understand this?
Nope.
Keep your head straight. As long as you have good notes, you should be able to have no problem. I think the key to these problems are just having good notes, whatnot. Now, I'm going to change this from L to a C. Okay, just change this to a C. And see what happens now. If I do this, keep the same numbers, for ease of calculations. Let's just see what difference would that make as far as our formulas goes. Well, obviously, when I go in there, I'll find this method right here. And this method was I sub c. This would be I sub c. This would be, that would be equal to V sub cell, V sub L, V sub R actually. All the same. Pretty much the same.
That would be positive
Now-
arctangent.
Yeah, yes, it's exact. So what I have to do is I gotta change, take a look at this a bit. First of all, I'll draw the phasor on this one. The phasor is going to go upward and this one here is going up. So I have, I see 1, 2, 3, 4, 5, 6, 7. Eight, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this guy over here is gonna go, I sub R was 16, I believe, which is going this direction. Just gonna change the scale a little bit. So this will be I sub R, this will be I sub C. This going upward. Then I have over here I total. Notice that's gonna be positive now. Phase angle. And so I sub R was V over R. If I keep the same thing I had before, it's 80, at 80 there. Same thing as I had before, no changes here really.
So
Everything's the same.
the tangent,
16.
it will change the tangent the I sub L on top, wouldn't it?
I'm sorry, what did you say?
For the tangent, will we still need the I sub L?
No, I'm gonna change everything.
Oh, okay.
I'm still,
So you're
I'm
working
still
on-
trying to find I sub L, I don't have I sub L anymore, I have I sub C.
Okay.
I sub C is V over X sub C now, which was 80 over, in this case here, 8K, 10 milliamps. So what happens is that I total doesn't change by the way. I total is going to be equal to square root of 16 milli square plus 10 milli square, which was, we came up to be, I believe was 18.9.
Yeah.
18.9 milliamps. So we can go ahead and change some of these guys. This was I sub, our tangent
C.
of I sub R over I sub C, right?
No, it's I sub C over I sub R.
So I sub C
Yeah,
over
I sub C
R.
over
So that really had
Thank you.
that. Ready to
That's
do that. Yeah.
Which is going to be a positive number,
Right, let's see.
plus. And over here, we had plus. So this angle would be negative. And that would be for Z. But the current would be, the angle of the current would be positive. As far as the current is concerned. Everything else is the same. I sub C. Notice the change, there was not very much in terms of change. Very much the same formulas we used to get this answer. When it comes to here, pretty much the same, except the angle has changed. This will be negative now. This will be X of C. Angles will be negative. Negative. I believe. this minus minus becomes positive, so it becomes, this will be positive actually.
Why don't, I have a question.
Yes.
You know, like for the formula, Z equal RXC over R plus XC, why you don't just put the square root up there? I'm just saying like on the, go up.
On the product over sum.
Right here?
Yeah, why don't put like square root of square root
Okay,
R.
this, remember the Ohm's law in the parallel circuit, we have product over sum. Then we have two resistors. Remember we had two resistors, this has R1, and we had R2. And if we had the parallel circuit, R total, we use R1 times R2 divided by R1 plus R2. Do you remember this formula?
Yes.
It's the same thing, except instead of R2, I have X of L. So this times this divided by this plus that. That's product over sum. That's what I'm doing here, except when I was doing DC, we didn't have to worry about the angle. Now we do have to worry about the angle. These are vectors. So when we multiply, we have to multiply them like a vector. We add, you have to add them like a vector, which is the magnitude and that's the phase angle when we add those two vectors. And,
Good question.
yes,
How do you divide? I mean, if you divide a positive degree over a positive degree, how do you end up with a negative degree?
okay, because this is a denominator. For me to bring this into the numerator, I have to change the sign.
Oh, yeah.
This from denominator to
Numerator.
numerator, it's just a law of
Yeah.
math. And there's nothing we can do about it. It's not-
Okay, 90 minus negative 58, that's gonna, oh, sorry, I didn't mean to interrupt. That's gonna be negative, that's gonna be positive 148, right? So where do you get that negative 32? Oh, that's just like 180 minus 148?
From minus to plus over here, I guess this will have to be, this will have
90
to
would be
be
negative.
negative 90.
That's
Fifty-
negative
This one
90.
has to be positive 58, no?
Yep.
Yeah. Yeah.
Wait, was it negative before? No,
No,
I thought it was positive.
It is now because it's X of C falls below the, X of C falls below the zero line.
Face of, the
X
face
of
of
C,
number.
not X of C.
Oh, X of C falls.
X of C falls below.
So when you're trying to find
X
X
of
of
C
L,
goes up, X of C goes down. You see?
So X of C is gonna be negative 90. No, that's be positive 58.
positive 90, yeah.
Yeah, on your graph over there, it shows going up. Think about,
Well, the current goes up, but the impedance goes down.
dominoes.
This man. Hello? Yes.
Mackin. Mackin.
Yes.
Okay, makes sense. Minus 32.
Pretty much all the
Positive 30.
all the signs change from positive to negative.
Yeah, yeah, because it's just opposite. That's the only thing different.
Okay, actually, your copy right now in the middle of something.
Chicken in.